Binomial distribution. Binomial distribution was discovered by James Bernoulli in 1738. This is a discrete probability distribution. A discrete probability distribution applicable to the scenarios where the set of possible outcomes is discrete, such as a coin toss or a roll of dice, can be encoded by a discrete list of the probabilities of the outcomes known as probability mass function. The word binomial literally means two numbers. A binomial distribution for a random variable x, known as binomial variate, is one in which there are only two possible outcomes, success and failure, for a finite number of drugs. For example, if a new drug is introduced to cure a disease, if it either cures the disease, it is successful, or it does not cure the disease, it is a failure. If you purchase a lottery ticket, you are either going to win money or you are not. A machine is known to produce on average 2% defective components. As an engineer, you might need to know the probability that 3 items are defective in the next 20 produced. Basically, anything you can think of that can only be a success or a failure can be represented by a binomial distribution. The definition of binomial distribution: if x is a discrete random variable with probability mass function p of x is equal to ncx p power x q power n minus x. The q is equal to 1 minus p. Here x is equal to 0, 1, 2, 3 and so on n. Then x is a binomial variable, variate, and the distribution of x is called binomial distribution. The problem. Here, example, a quiz consists of 10 multiple choice questions. Each question has 5 possible answers, only one of which is correct. Pat plans to guess the answer to each question. Find the probability that Pat gets one answer correct, all 10 answers correct. So, such a case, we use the binomial distribution. The probability mass function of the binomial distribution is probability of x is equal to ncx p power x q power n minus x. So, from the given question, n is 10 and p is equal to 0.2 and q is 0.8. The probability of success plus the probability of failure should be equal to 1. Here we have the value for the probability of success is 0.2 and the probability of failure, because it is the 1 minus p, it is 0.8. The first one going to find the one answer correct. The probability of one answer correct, here x takes the value x is equal to 1. So, substitute the values x, p, q, n in the given equation. After calculating it, got the probability value 0.2684. Then calculate all 10 answers correct. The probability of all 10 answers correct, here x takes the value 10, substitute the all values in the given equation, and finally after calculating it is 0.000001. Chance here we have. One more example, 2 dice are thrown 5 times, find the probability of getting 7 as sum. At least 1, 2 times, the probability of 1 is less than x less than 5. So 2 dice are thrown, we have 36 possibilities. In these 36 possibilities, getting a sum is 7, we have 6 possibilities. So our favorable are 6 and our exhaustive are 36. The probability of getting success is 6 by 36, that is simplified is 1 by 6. Q is equal to 1 minus P. Probability of not getting is sum 7 in a single throw of a pair of dice. We subtracted the P value from the 1, then we get the probability of the failure. It is 5 by 6. So from the given problem, the number of trials is 5. So here we are using the binomial distribution, the formula NCX p power x q power n minus x. So calculating the probability of at least 1, symbolically we will write it as a probability of x is greater than or equal to 1. Probability of greater than or equal to 1 means we have to calculate all the probability values is more than or equal to 1. And we will remake it is like a 1 minus probability of x is equal to 0. It is easy to calculate, only the single observation, simply we are subtracting it is from the 1. So here the value tells 0.5981 is the probability value to get at least 1. Probability of exactly 2 times. So here x takes the value is equal to 2. Substitute all these values in the given formula. Then we have the 0.0268 chance to get the probability exactly 2 times. Then probability of 1 less than x less than 5. The values are taken here. Probability of x is equal to 2 plus probability of x is equal to 3. Probability of x is equal to 4. Substitute it and add it individually. Then you will get the value 0.1867. In a college, 20% of the students are girls. In a random sample of 5 students, find the probability that there are at most 2 girls. Let x be a binomial variate denoting number of girls with the parameters n is equal to 5. The p is equal to 20 divided by 100, so 20%, so it is equal to 0.2 is the probability of success. Then the 0.8 is a q. So binomial distribution, here we are using NCX is p power x q power n minus x. So probability of x is less than or equal to 2, take the values, probability of x is equal to 0, probability of x is equal to 1 plus probability of x is equal to 2. And after substituting and after adding all these 3 probabilities, then we got the 0.94208 is our probability value to at most 2 goals. Fitting a binomial distribution. 4 coins are tossed 160 times. The number of times x heads occurs is given below. Fit a binomial distribution to this data on the hypothesis that coins are unbiased. So here we have the values. X takes the value 0, 1, 2, 3, 4. And number of times 0 appear, number of times 1 appear. Like head, how many times 0 indicate no head, 1 head, 2 heads, 3 head and 4 head. The data is given. The coin is unbiased, already given in the question. So the coin have equal chance to get either it is head or tail. The probability of getting head, the success is 1 by 2. The probability of getting not head is also 1 by 2. And n is 4. The probability mass function of binomial distribution is NCX p power x q power n minus x. So already in the given question we have the x values, x takes the values 0, 1, 2, 3, 4 and the number of times, the frequency is also given in the question. And then calculate the probability of x for each and every probability value. Then multiplicate each probability with n, that is equal to 160. The observed frequencies and the expected frequencies should be equal. If the frequencies are equal, then we call the distribution is correct fit.